Hey, hello everybody, and welcome to Job City's Lunch and Learn. As you guys know, we bring this monthly program to you guys to talk about new and interesting topics in the world of tech. For today's topic, we have Victor Garces, who is a developer from Dominican Republic. He will be talking to us about Go, which is this fantastic language that has been recently developed and it has gained a lot of new followers. So if you've been looking for an excuse to take a look at Go, or if you're just looking for a new language that you want to try, maybe this is the reason why you should go with Go. Victor, hi, how are you?
Hi, Sebas. Thank you for the awesome welcome. I'm really excited to be here and the opportunity at Yup City to talk about this topic and language that I really appreciate, which is Go. So today, I would like to start talking about Go, a simple introduction to the language for those developers that are interested, as well as I am, in this programming language, and maybe for those also that are already mid or even senior developers that are just here to refresh some concepts and maybe learn something new, since we never stop learning. So with that said, I will start with the famous hello world. You know that every developer always has to start with this simple sentence, since it's like the entry point for us to the programming world. So here I would like to start with the most basic syntax of the language to start typing something, but let's do it on the IDE. So yeah, here we are in VS Code. So you can see here, when you start typing code in Go, you start here with the package declaration, which is in this case is the main. Also, this is required since this is the entry package for the application to start running. Then we have the imports, which are the packages that we are using on the application. If you're coming from the other languages, for example, like .NET, as I do, or C#, you may be familiar with the usings and all the stuff. Here we use the imports. And then we go to the main function, which is the entry function that will get executed when we start running the application. There are a lot of packages and tools that we can use here. For example, I can just run this application from the command line, typing a simple commands like go, since it's the main keyword here, run, and the name of the file that I want to run. In this case, the hello.go file. And easy. With that done, I just here print on the command line a hello world message. So you might say that I'm already an entry developer or entry Go developer if you want to. So okay, moving forward, here we have some features. Most of the most basic features that we have on the programming language. Go is a modern language. What I want to say with that, Go's first appearance was in November 10, 2009, by a team of Google engineers that wanted to write a language that was more efficient and to solve software engineer problems. That's the reason of the appearance on Go. And also, like an interesting topic, that's the main reason why there are a lot of features that are outside the language. For example, the some operators that may be fun to use or easy in other language, they are not here because they just thought that wasn't necessary and they just make the language more verbose or hard to read it. It is also compiled to native code and is statically linked. What does that mean? It means that it makes it easier for us to port it from one system to another. It also has built-in concurrency support, which is awesome depending on the system that you are developing. In this case, for the Google team, it was a must for them since they work with high-scale projects. It is also compact, concise, and general purpose. It means that you can use it virtually for everything you want. It doesn't matter what kind of project you're working on. Although, there are different programming languages for different purposes. It is statically type check and dynamically type safe. It also has a garbage collector, for those that don't have it. It's fast compilation and efficient execution, as you just saw, even though it was just a hello world. It's really fast when you are coming to run the application. And you can use it on Android. As I said, you can use a virtual for everything. And here's a joke, accept Java developers. Just kidding. Here we have another hello world. Again, but different. I just try to make it a little harder, but just for you to see the simplicity of the language. Coming back to the ID, here I'm just turning on a web server. And you may say like, wow, you can do it just with 2 functions. Yeah, you can do it even with less than that. Here again, package declaration. I know that you're a master with that already. Here are the imports. Now I'm using 2 different packages. The log, because it's a best practice to log the information or what's going on in our services, just to know, if we have a problem or an error or something. And the HTTP package. All these come from the standard library. Just take that into consideration for the layer reference. So then we here declare, okay, we are declaring our first function, different from the main, which is hello server. Here I'm receiving 2 parameters, the response writer and the request itself. What I do with them? First of all, I like to, print the URL or the path that I'm receiving, just to have a reference of from where I'm getting the request. And then I will print in the request a custom message. In this case, a hello world and the same URL that I'm receiving. And return that to the response. Then if we move forward to the main function, we first print on the console line a message to know that our application is running. And we declare the path where our application will receive the information on the request that we are declaring here. In this case, I just call the HTTP package and call the handler function, which takes 2 parameters, the path, in this case hello, and the function that we already read. And for the last and not least, we are calling here a log.fatal in case that we get a fatal error, and turn our application, listen and serve, and declare the port where it will be running. So it may seem like a lot of information, just reading for you a function and stuff, but let's see in action. If I call again the go run server the go file, you can see here, as I mentioned, it executes this function and print the line, what's going on, please connect to this port. So if I come here to the browser and refresh, you will see here that I'm receiving the hello world message, which is this one here, and the URL plus the variable that we declared before. In this case, this variable is coming from these parameters. This is just a way like the FMT package work, at least with this function, or you can declare many variables and pass as many parameters as you require. So yeah, that's just an observation. That's the reason here why we receive URL equals hello path. What happens if you try maybe, accessing to a different path that we haven't declared, like hello without the H? We say, hey, 404 page not found, because that doesn't exist here. And just that easy, we have now a web server running with a path and a logic implemented in a function. In basically what? 18 lines. We are developers right now. So let's keep moving forward. There are more features. That's the reason why I love Go. They will have something to surprise us. Between the more features, there is a static build. That means that we don't need a bunch of packages in order to run our applications, except that we were working with something like C, for example. In that case, we will have to add a package called cggo, which also can be removed without any problem. There are also great tools. As I just showed you, there is the Go tools, for example, to run the application, but many others more useful. For example, the Go FMT, the Go doc, the Go imports. They all have many uses. I don't know them all because there is a lot of information. But we also have a Go test. All right, we have a built-in test package here. So don't worry about that, because that it's a best practice to always test our code, right? It is also a neutral language. What does that mean? It means that it has a simple syntax, it's easy to cache, it's fully UTF-8, although It's easy to catch, but it's hard to master. Just take that into consideration. And it's also multi-art and cross-compiled. You can run it in any OS that you want to work on. So okay, let's move to concurrency. Concurrency is one, even though this is a simple introduction, is a must topic when you are talking about Go. Why? First, because this is one of the main purposes why it was written, in the first place. And also because most of the applications that are written that really require or need to work with this language apply the practices that comes with concurrency. So yeah, before moving to the tools that Go uses to handle concurrency, let's first have a main idea of what concurrency is. Simple described, is when you are doing more than one thing at the same time. Not to be confused with parallelism. That's the reason why I wanted to do the declaration. Concurrency is when multiple sequences of operations are run in overlapping periods of times. And you can see here with this little image that I have here. Let's say that there are many tasks running, but they may be using the same single source for that. In the realm of programming, concurrency is a pretty complex subject, and it can cause to many problems if you don't know how to manage or handle properly. This will be the explanation for parallelism when there are two or more tasks running at the same time. But for concurrency, it doesn't mean that they have to run at the same time. It's just that you're handling many tasks. So yeah, the way Go handles them is first making use of the Goroutines, and second, making use of the channels. They both work together, but they are separate topics. So yeah. Sorry. Goroutines. First, we need to know what is a goroutine. A goroutine is just a lightweight thread of execution. It's not the same of a thread. While in language like C# or .NET, let's say, you usually work with many threads doing, some task or something, some logic. Here you work with goroutines. The benefit of the goroutines, or the reason why they are lightweight, is because you can have many goroutines in a single thread. With that, you can be working with thousands or millions and doing a bunch of operations, which make it more useful than the threads and less consuming. But it comes with a trick that you will see later. The Go statement launches a function called as a goroutine. You will see in the code soon. And a goroutine runs concurrently, but not necessarily in parallel. That's the reason for the differentiation. And also, a goroutine has its own stack. That's to avoid, problems with reference of many goroutines accessing at the same object or reference, which will make a headache of coding. So let's go to a goroutine example. If we take a close look here, okay, I'm using the same package declaration. We already know how to use the imports. Here I'm using a different one, the time package. And first I declare this function. What happens here? You receive, please don't mind the naming convention here. I know that you guys know how to name functions. This is just for example purposes. Here we receive the message first and a delay or a time duration for what we are going to do here. With this for operation, it's just executing one and another, printing the message that we are passing here, and then sleeping the code or just waiting for the amount of time that we pass here. What happened then? Here comes the fun part. In the main function, I'm using the Go statement, which I mentioned here. The Go statement launches a function called as a goroutine. When we call this function, which is, if you see, it doesn't have anything weird or different that we just saw before. But when we use here the Go statement, it calls this function as a goroutine. What does it mean? It locates the function in a routine inside a thread, which won't block or main code. It was just get executing. So here we are calling 3 goroutines using this, calling the same function using the same statement but with different parameters. And at the end, we wanna wait for 20 seconds just to keep the application running while you see what's going to happen. So if I go here, go run routine.go file, you notice that the three of them are running at the same time. It doesn't mean that they have to run in order. That's something you have to take in consideration. Even if you have here different time lapses like 300, 500, and 1100, it doesn't mean that they are going to wait one for the other. So if I, for example, change the value here, you may say, okay, we will print the information ABC. Let's see if you are right. And you can see that no, that's not the case because the goroutine aren't necessarily called in a specific order. Sorry. So yeah, that's basically the main idea of how goroutines run. They are just running in a different thread, if you want to say it. And it's pretty useful when you are maybe calling some information from a separate API or a bunch of logics that you may want to do in your projects. So with that basic explanation, I think that we are almost raising the mid-developer. But let me just help you with a little bit more of information. Here we're using the second tool required to handle concurrency in Go, the channels. What are they for? Channels are the pipes that connect concurrent Go routines. I know that you may be wondering, hey, if they are running in different ways and they all have their own stacks, how do I handle information between them? That's the reason why channels come here. You can send values into channels from one goroutine and receive those values into another goroutine, which is fantastic for our purposes here. If you see here the example, we are first declaring the channel, which has to be open with the built-in function make. Then we pass the keyword chan, declaring that we want to open a channel, and then the data type. Then within a goroutine, which is just declaring one line here, we're passing the information. That may seem weird now, but yeah, that's how it works. We make use of the arrows to point where the information is going. But let's see in action because it's easier for us to understand that way. Okay, here we have the example of channels. Here, if you notice, it's almost the same function that I was using before. It's basically the same. But the only difference here is that I'm using now channels. And you might say, why? If you notice here, now when I pass the message to the function, I also send that message to the channel that I'm just receiving as a parameter here. And you might think, wow, why I'm doing that? Well, I'm doing that because I just want all the goroutines to work. Let's say that I have 3 workers and I send them to do some different tasks. Each time that they have some result, I want them to put that information in a basket. In this case, the basket was, let's say that is this channel that we are working on here. So every time that they put that information inside the channel, it will be received here within this for loop. And in every iteration that runs here, I will just print the information that is coming out from that. So let's recap. We have our function receiving 3 parameters. We have our for loop here. We are passing the message that we are receiving into the channel, and then we are sleeping our code here. In this case, we are sleeping, let's say, this coroutine to stop working before sending more information. So let's see how it goes. If I write go run channel.go, we can see here that it's basically the same function. It's the same logic that we had here before, but doing or making use of a different tool, in this case, a channel. So you know that you can share information between goroutines using the same source of information or source of truth, in this case, the channel for that. And I also print the index just for reference for you to know what's going on here. And yeah, that was a little bit of channel example. You might think, okay, now that I know that, let's say, I don't know, and I'm a Go developer. I know how to handle channels and Goroutines, and there is nothing that can stop me. Yeah, that may be true, but there are some stuff out there that you may be missing. For example, the channels by default. Let me check. Okay, here. Let me first go into that before placing more examples. A channel type specifies a channel value type. As I just mentioned, you first declare the channel, meaning that it's a channel that you are declaring here, and then the data type. You may specify the direction or the communication direction of the information here. For example, if you place the arrow in front of the keyword here, it is a send-only channel. And if you do it that way, like before the channel keyword, it is a receive-only channel. It may be tricky, but sometimes they are useful because you don't want the information going both ways for some reason. A channel is a variable of a channel type. You can see here the var declaration, the name of the variable, the channel keyword, and the data type. And the way to initialize the channel is with the really make function. And that's the way that you send and receive information that you already know. But what happened? By default, the channels are on buffer. What does that mean? You may have by buffer I mean that they are not supposed to receive information and just get stuck there. They have like a buffer where they can place information for someone that is not using or expecting them. What happened with with that simple trick or meaning for you? Let me show you. Let's say, for example, here we are in our main function, which is also a Goroutine, but that's another topic. We declare here first the channel string type, and then let's say that I remove this stuff here. I don't want to use it. And I say, hey, I have a channel here. Here I pass an information, as I just saw here. I'm receiving a string message called ping into this channel, and then I'm just passing that information to a variable that I want to print out. Any problem with that, right? Well, that's not the truth in this case. Here you receive this kind of error. All routines are asleep, deadlock. Why? Because the channels are block operations. What does that mean? That when this happens, if there is nobody expecting or waiting for the result in the other end for the channel, it will block the thread or the routine in this case until somewhere receive the information. That's the reason why if you want to do some kind of action like this way, you have to use what we call the buffer channels. To do that, you have to declare the amount of or the size of the channel before using it, and that way it'll be better for you and it will work for you. Just that simple. If I wanted to make it work without the buffer channel, I would have to use a Goroutine. Why? Because it is running in a separate thread in this case, and it won't block my operation here. Sorry, that's not true. It's running a separate Goroutine, and since the main function is also a Goroutine, they are running in separate operations, and one won't block the another. So if I make it run this way, a Go function, and I pass the information here, I'll get the same result. I hope that may be interesting for you guys. And I thought I have something else. Yeah, that's it. Yeah, you might think, hey, you will give me a lot of information, a lot of stuff to think. And I know, let's say that, okay, I already know how to work with Goroutines. I know how to work with the channels. I know what happens if I'm not using it the right way, or if I'm not using the buffer channels, this and that. But let's say that, okay, you have maybe, you're working with several Goroutines. Let's say that you're working with thousands of Goroutines in, a real world project. And you are are waiting for the result of them to get through multiple channels, not just one or two. You're using many channels, many routines, and you need to expect the results of each one of them. How do you do that? Well, for that reason, they also add one more tool, the holy select. It's not really holy, but yeah, just to make it fun. The select keyword lets you wait on multiple channel operations, and combining Goroutines and channel with select is a powerful feature of Go. And if you handle that, you may consider yourself mid-senior or something if you want to. So, and to prove that, let me show you an example. Here we are making use of the select statement. We start here opening two channels. I know you're a pro with that already. Channel 1 and 2, really original. And then we declare two Goroutines. The first one will sleep for 3 seconds. It's really, clear here, second per 3. And then it will pass a message to the first channel. The other function will do basically the same, but this time we'll do it in 2 seconds and we pass this message to the second channel. But what will happen here? Here we are running a for each step, a for loop here in this case. But we are using the select keyword that I just mentioned to check between the channels that are receiving information this time. Like it keeps running, expecting for information coming from one or the other. And when that happens, it will place information in this variable that we are declaring here. And in this case, just print the information as received and the message. And let's make it run. Three seconds. Boop. And that's it. As you can see here, I was making use of two channels, and I had two Goroutines running at the same time, even though they have different implementation and are doing some logic. I can expect and wait for information from several Goroutines and several channels, and handle different operations and have different logics when I'm doing my work here. Just thankful thanks to this keyword that we have here, the select statement. And with that said, I can say, hey, is this concurrency? So yeah, basically, yeah, you are already working with that. Even though this is the the basic steps you need to know before running to work with real world projects. But now that we know how routines work, how are they declared, they have their own stacks, how to share information between them, making use of the channels. Some of the stuff that can happen while using channels, there are more information, but you have the basic knowledge to work with them. And also, you don't have to use the select statement here. You may be prepared to say, hey, I'm a senior developer if you want to. But even though I've been having fun and saying all the good stuff on Go, and that's not all the truth. You need to know the not so funny parts of the language. First, maps are not thread safe. Yeah, you may say, yeah, this is fine, but no, they aren't. And I say that because when you're working with Goroutines, you may have or face problems. And we're trying to access some kind of objects or information, even though they are in their own stacks. Why? Because let's say you're trying to access the same source of truth from two separate Goroutines. That definitely will cause a deadlock for you. So to avoid those kinds of operations or situations, I suggest you to maybe read or learn how to use the mutex and also atomic counters. That these are the most common practices to avoid those kind of or to face those kind of situations. But yeah, they are not very safe. And also the error handling. As something may know, in other languages like C#, for example, you just throw an exception, and you know that this will stop your application, or you can handle it that way. But here the errors are handled as values too, as you would treat an integer or something else. And for that reason, you have to work with them that way. And you may end having codes or functions with infinitive if statement just validating that if an error came or not. So even though the panic and recover are good tools that you may use here, please never abuse it because the next day will come another developer working with that and it won't be fun. And you never know if it happens to you too. Here also, like just closing here, there are more sources that I hope if you're interested, you may give it a try and try looking for information here. These are specifically the ones that I use and some that I recommend for you guys to read on. I can pass more on the chat if you want, but these are like pretty valuable source information for me. And that's it. Hope you guys enjoy.
All right. Thank you, Victor, very much. It was a nice presentation, very eye-opening about Go. Personally, it's a language that I've heard about a lot recently. Lots of these new features that languages now see as a must. Maybe older languages didn't take into consideration. Go just uses them as a basic thing of the language, which is very interesting. So thank you very much, Victor. As usual, guys, if you have any questions, you can send them either through the chat right now, or as usual, you can find us on the Slack channels. Victor and I will be there listening to your comments, to your questions throughout the week, the rest of the week. And if you guys have any interesting topic that you would like to present to us for our Lunch and Learns, feel free to reach out to either us or our marketing team, and we can make that happen. Again, thank you, Victor, very much. I don't see any questions on the YouTube channel. It looks like your presentation answered everything that we may need to know for starting. So for now, I guess I'll say goodbye. Maybe Victor, if you want to say goodbye to everybody, now's your time.
Thank you, Seba, Simon, and all the team that gave me this opportunity. Like I really enjoy doing that, and I hope that everyone like watched the presentation, learn something from here. I hope that that's the reason why we have questions now. And if you have any question, don't hesitate to reach out. I'll be always open to help you guys to come here to the World of Go development. And yeah, until the next one.
Yeah, definitely interesting. Until the next one, guys. See you next month.